Hey guys, so kinematics is actually the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. Kinematics is a branch of mechanics. The goal of the study of kinematics is to develop sophisticated mental models that serve to describe and ultimately explain the motion of real-world objects.
So that definition came straight from iPodphysics.com. That's Mr. McNeil's website. But basically, kinematics boils down to the study of motion. So two very important terms that we should distinguish right off the bat are the difference between a scalar quantity and a vector quantity.
So a scalar quantity is the first one, and the way that Mr. McNeil describes them is dumb. They're dumb measurements, they're dumb magnitudes, because they're lacking in one specific thing, and that thing is actually direction. The difference between a scalar and a vector is direction. So it's like if you say, I moved 10 meters, that's like giving us a scalar model.
It's a scalar. Whereas if you said, I moved 10 meters to the east, that's a vector because it has a magnitude and a direction. So those are the two key words, magnitude and direction.
And the key difference between vectors and scalars is actually direction.
Yeah.
So it's like if there's a problem and it doesn't give you a direction that it moves, then it's a very odd problem, and it's not.
We probably will not get those problems.
So it has Mr. McNeil if there's one like that.
Yeah, I don't think there is an AP Physics though, so it's all right.
Yeah, and that's a specific thing that we'll talk about a little bit later.
Really, the only important scalar that we ever deal with is time, because time is a very important relation, and especially when you're dealing with two-dimensional kinematics. And so let's talk about one-dimensional versus two-dimensional kinematics.
Yeah. So one-dimensional kinematics is actually the way that an object moves in one direction. So it's like it either moves horizontally or vertically. It doesn't move in any curve. It doesn't move upon like a Cartesian coordinate, so like x and y. It only moves in the x direction or the y direction.
Whereas two-dimensional kinematics is essentially kinematics within two directions. So you have like, it's essentially a parabolic arch, like throwing a ball and you're testing. It gives you the acceleration at the beginning, and you're testing to see. It'll give you like It'll give you some quantities in the horizontal direction and ask you to find things in the vertical direction.
And we talked about time a second ago, and that's how you link the two. It's like between the two dimensions, x and y, nothing is the same except
for time. So time is what you use with your equations that we'll talk about later.
So it's like if you solve something for the x direction and you solve for time, you can solve how far it goes in the y direction.
Yeah. All right, so now let's talk about some of the key vocab terms. The first one being position, which is the location of an object, and the position is really the f of x. The f of x function, meaning that it would be like in a position versus time graph, and that's where you get your velocity and acceleration derived from.
Yeah, so position, a really important part of position and understanding position, and therefore one-dimensional and two-dimensional kinematics is actually the difference between displacement and distance. Now, you might have heard displacement talking about that Greek legend or whatever that had to do with the guy dropping the crown in a mountain of water. And see how much it displaced it for density. But that is not the same displacement as we talk about when we're talking about...
Oh, you're talking about the bathtub guy?
Yeah, the bathtub guy with a lead
Eureka!
Crown. Oh, was that him?
Yeah, he got in the bathtub.
Oh, right, he's the one who said Eureka.
Yeah.
Anyways, so displacement is how far an object is displaced from its starting point. So if an object starts at the origin of a Cartesian plane, and it moves 10 meters in the east direction and, say, 30 meters in the north direction, then it's going to be the...
So what he's trying to get at is it's essentially a triangle, which is where your Pythagorean theorem comes in, because you're moving 10 meters up and 30 meters east or west, doesn't really matter in this case. And then so what you do is you use, because it's a right triangle, use the Pythagorean theorem to find the hypotenuse, which is your total displacement, which is a lot different from distance, because distance would be adding those two values together.
So it's like the displacement is going to be something around like the square root of 1,000, but I don't know what it is.
It's like 31.6 or something like that.
So it's 31.6, but our distance is that 10 plus that 30. The total distance traveled is always going to be equal to or greater than the displacement, because that's 40 versus the 30, and that's always just a key property that you have to keep in mind.
You'll basically travel farther than you're typically displaced.
Yeah.
Go into velocity now.
Yeah, so if you go back and you remember that we said f of x, so the function of x is the position of a graph. If you take the slope of that graph...
of a position versus time graph.
Of a position versus time graph, you're going to get velocity. And a way to describe that again is change in position over the change in time. And that's your basic definition for velocity.
Very important is velocity is a vector quantity, which means that it has to have both a magnitude and a direction. So, for example, negative versus
like
positive
you're moving,
velocity.
Say you start at exit 215 of I-25, and you're moving down the road 65 miles per hour towards...
You're going slow down I-25.
Yeah, well, I don't drive, so...
Handsome obeys the rules.
But you're going... And then you're trying to get to exit 250, and that's south of what it is. So it's like you're moving at 65 miles per hour south. And that is going to be velocity. But if you're just moving at 65 miles per hour, that's just going to be speed, and that's an important definition. It's going back to that scalar versus vector quantity. Again, since it's velocity, it's a vector, so therefore it has to have magnitude and direction, versus speed just being a scalar with magnitude.
And so, back to what we were talking about, velocity is, in calculus terms, the first derivative of a position graph, essentially. And so then the second derivative is what we call acceleration, which is, as velocity was a change in an object's position over time, acceleration is the change of an object in an object's velocity over time, which is also a vector quantity. And for the purpose of most of the physics that we're going to do, we're dealing with what's called static or classic kinematics, which means that acceleration will never change. Acceleration will always be constant.
And that's a really important definition. There's a page for acceleration on the actual website, and it basically what it boils down to is that acceleration is always constant for any AP calculus, or
not even AP, for anything that we do, physics class,
basically any physics class until you get to advanced material is going to be acceleration is constant. You're not going to get into where it's dynamic.
Complex harmonic motion.
Yeah, let's not do that. So acceleration is also a vector, and one important differentiation to make between acceleration for acceleration is the difference between used in physics terms and used in everyday terms. Because car companies are always saying that this car can accelerate
from 0 to 60 in like 10 seconds or something.
Yeah, 0.2 seconds, whatever, who knows.
But that's not necessarily true, because that's not talking about the change in the car's velocity. That's just car lingo to make you buy things.
Yeah, and acceleration can be negative. There's no such thing as deceleration in physics. It's just a word that has been made up and now has the
it's like cold and heat, basically.
Yeah, it's like but acceleration can be in the negative direction. So say you're moving like 60 miles per hour this way.
I mean, no, better example would be just gravity.
Oh, go for it.
Gravity is just gravity will always be negative 9.8 or 9.81 meters per second. That's the acceleration due to gravity,
on the planet
g, and that's the gravitational constant. So yeah, that's just a great example of acceleration.
Yeah.
But like if you throw a ball up in the air, it's always going to be experiencing that negative acceleration.
Yeah, so it's moving in the positive direction, but since gravity is pushing down on, or like pulling down on it in the negative direction,
it's going to have negative acceleration.
It has a negative acceleration, even though you think it's moving up in a way.
Well, it is still.
Well, it is. Yeah.
So its velocity can be positive, but the acceleration will be negative.
But if they are different, there's always going to be a point when the ball stops in the air and then starts to move back down.
And that's on the parabola. That's like the maximum point, basically.
Yeah.
Okay. So, I mean, that's kinematics.
That's basically kinematics. And then below this video, there will be another video of us two solving a kinematics problem. We're going to focus right now on one-dimensional kinematics.
We may even go into two-dimensional a little bit later.
Yep.
So, stick around.